I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will understand how do we simplify radical expressions. We have 10 examples for you. Simplify each expression with square roots. Now, whenever you have expressions with square roots, we also call them surds. Basically, these are irrational numbers. So we're talking about surds, and whatever comes inside the square root sign is called radicand. So when we say simplify each expression with square roots, we also sometimes write simplify radicands. They are similar terms commonly used. So, for examples, you can see now we have considered a simple radicand and then product of the two we have written in the powers and then with the quotient. In second set, we have variables involved. So you can see 2 square root 50 x cubed. So now we'll see how do we simplify each expression with variables. So that is the variable involved. A very important question, square root of x squared. And then we have 1 in which we have variables in the denominator also. Question number 3, we are now talking about rationalization. Now whenever we have to simplify in the denominator, we cannot have a surd. And therefore, we need to rationalize. I think you got the set. You can now try how do we solve them. And then we'll also have a bonus question. So that is the bonus question for you, which you can try after doing these 10. But before we begin, let us try to understand what are we doing indeed. Now, first thing, you know now what a radicand. Radicand is an expression under the radical sign. So whenever we write something like this and we write something here, let's say ABC, then the number along with the variables whichever come here, we could have a number also here. This part under the square root is called radicand. Now when we say simplify radicand, it really means what? Mainly it means two things. One, radicand will not have any perfect square factor. So within the square root, if you have a term like 9, which is a perfect square, then you can write 3 outside. So that is the first. So radicand will not have any perfect square factor inside the square root. That is radicand. Second is, radicand will not appear in the denominator. So if it does appear, then we need to rationalize. And that is why we had the third set of questions to rationalize. So I think you got the complete concept of what we're trying to do. So here, we need to simplify this. That means from 8, we have to remove 4 because 4 is a perfect square. Now a cube has a square. So that has to be removed from here. And 27 square root will give you 3 square root in the denominator, which needs to be rationalized, right? So that's what it means. So I hope this concept is absolutely clear to you. Now, you can pause the video and answer this question, and then look into my suggestions. Well, in case you want to learn from me, you can always send an email on the address given.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our summer classes and get ready for bright future.
Many of my students have performed very well. I hope my videos can help you also. Now, let us see, how do we solve these questions? A quick note on what we learned just now about radicands is summarized here. So, we'll simplify the radicands, and simplify radicands means, as you know, two things. Radicand will not have any perfect square factor, and radicand will not appear in the denominator. So basically, I have given you here the comparison, not simplified and simplified. Well, both are radicands, both are surds, but this is not simplified. When I say square root of 27, 27 can be written as 3 times 3 times 3. So basically, when you do this square root, you know 3 times 3 is 9, and 9 is a perfect square. So that is taken out as 3. So this is a simplified form. You get the idea. In the second example, we have a radicand in the denominator. We need to rationalize it, and that is to say, multiply and divide by square root 3 in this particular case. Now when you do that, the square root 3 times square root 3 is 3. So now we have a denominator where there is no square root sign. And therefore, it is treated as simplified. You get the idea. In the numerator, 7 gets multiplied with 3 and we get 21 within square root. And the factors of 21 do not include a perfect square. And therefore, we say that it has been completely satisfied. And so, it is a radicand in the simplest form. Now here is another very interesting, we have taken the variables. Now PQ could be written as P square times P, and therefore one of these P square can be taken out, right? Now in this case we have written 2P outside since 12 is 4 times 3. You get the idea. So think like this, 4 times 3 times P square times P times Q. This is not simplified since we have a perfect square, also a variable which is squared. So both can be taken out as 2P and simplified. You get the idea. Use these concepts now and then simplify and write down the solutions. So let's now go through these solutions quickly. You know all the concepts, correct? Simplify each expression with square roots, means surds. Square root of 18 I can write as, we are looking for perfect squares, not within the square roots. Perfect squares not within square roots. Well, 18 has one, which is 9, and 9 times 2 is 18. 9 can be written as 3 square, and therefore 3 can be taken out. Square root of 9 is 3. Now this is simplified. Get the idea. So I hope with this the concept is absolutely clear. So now let's begin doing most of these questions. 72 is, you have to look for a perfect square. Can be written as 36 times 2, and 27 can be written as 9 times 3. Now 36 can be written as 6 square root 2, and we have 3 square root 3. This could be written as 6 times 3 as 18, correct? And within square root we have 6. That becomes the simplified form. When we are given in powers, for example, 2 cube, 3 square, and 5, you can clearly see 2 cube means 2 square times 2. So I can bring out 2 outside, I can bring out 3 outside. Within radical sign, we have 2 times 5, which is 10. So I could write this as 6 square root of 10. Is that clear to you? So in all these examples, we have only numbers, not variables. In the next set, we have variables. Now let's look into this. What is 343? Well, 343 is 7 times 7 times 7, right? Let's figure this out. 49 times 7 is 343. So I could write 343 as 49, which is square root of 7, and then times 7. And denominator 8 could be written as 4 times 2. Now this dot is for multiplication. Perfect. So I could write this as 7 square root 7 over 2 square root 2. However, we have square root 2 in the denominator. So we need to rationalize this. So I have to multiply by square root 2 in the numerator and in denominator. We cannot have a radical sign in the denominator. So that gives you in the numerator as 7 square root of 14, and in the denominator 2 square root 2. When you multiply them, then you get 2, and 2 times 2 is 4. So that becomes the answer. Is that clear to you? So we have done rationalization in question number 4. Now let's see, how do we solve the second set of questions? Well, question number 5 is 2 square root of 50x cubed. We could write this as 2, and 50 is 25 times 2. We are looking for perfect squares as factor of the number. Only then you can take them out of this radical sign. And as far as x cubed is concerned, think like this. And then you can rewrite this as 2 out of 25. 5 goes out, and out of square of x, we get x outside. We are left with 2x within the bracket. Now 2 times 5 is 10. So you could write this as 10x square root 2x, right? So let me use a different ink here. So 10 and then x and then square root of 2x. Correct. Next, square root of x squared. Many students think that square root of x squared is indeed x. Well, that is not correct. X belongs to real numbers. It means it could be positive as well as negative. So if x is negative, square makes it positive. So it is not equal to x. It is always positive, and therefore we'll get this as absolute value of x. Extremely important. And you have to use this whenever you have just x squared within the square root. Now, so even powers, remember that, even powers, right? So even powers means within the radical sign, x belongs to real numbers. Now in this case, we have 20, a cubed, b7, and square root. So in the denominator, you see we have square root c square, which means absolute value of c will be taken outside the radical sign. You get the idea. So that is very key. And if you don't do this, you have a wrong answer. In the numerator, square root of 20, we can write 4 times 5. So I'm taking out 2 this time, right? Let me go it in 2 steps. So we have 4 times 5 here, and then we have a square and a, and we have b to the power of 6 and b. So even powers, when divided by 2, will give you the variable outside. And 4 square root is 2, right? And then a square is a. Since it was a cube, we do not write a square because then a could be. A has to be positive, right? A cannot be negative. Otherwise, in this particular case, radical is not defined. Okay, so we have 2a and b to the power of 3. And within the radical sign, 5ab. Is that clear to you? And then absolute value of c. So that is how you will do this set of questions. So I hope it is absolutely clear. So what we figure out here, let me write a note here, that if I have, let's say, square root of, let's say, a cube, in that case, remember that a has to be greater than equal to 0. Since a is already greater than equal to 0, in that case, absolute value of a is indeed a, right? So we need not do absolute value of a. That is what I'm trying to say. Clear? Next set of questions involve rationalization. Now, if the radical sign is as shown here, we need to rationalize. So what do that rationalization do? Well, as you know, a plus b times a minus b. What is this equal to? This is equal to a square minus b square. So when you do square of a radical sign, it becomes a number, a rational number. You get the idea. So that is rationalization. So the a minus b, a plus b, these are conjugate of one another. So we multiply and divide by conjugates, right? So you use conjugates. So let's see how. So do the first one. What we are going to do here is that we got to multiply by 1 plus square root 2, right? And the same thing we have to divide with. That means you are effectively multiplying by 1. And that is not changing your expression. Your expression remains exactly same, correct? Make sense? Okay. Now, in the denominator, you can see we have a plus b times a minus b. 1 minus square root times 1 plus square root, which gives me 1 square, which is 1, minus square root 2 square, which is 2. Perfect. And the numerator, I'll multiply by 3. So I get 3 plus 3 square root 2. Now 1 minus 2 is minus 1. So we get negative of 3 and negative of 3 square root 2 as our answer. Is that clear to you? So go over it once again. Try to understand how do we rationalize. Now in the second case, can you now pause the video and do it yourself? Multiply by the conjugate and also divide by the conjugate of the denominator, which in this case is square root of 6 minus square root of 3. So when you do so in the denominator, you get difference of squares, which is 6 and 3 square. So we get 6 minus 3. In the numerator, you have to multiply by 2. So you get 2 square root 6 minus 2 square root 3. Make sense? Now, 6 minus 3 is 3. So you get 2 over 3 square root 6 minus 2 over 3 square root 3. Now, these are not like terms, square root 6 and square root 3, and therefore they cannot be simplified further. The last example here is square root 3 over 2 minus square root 3. If I multiply by the conjugate of denominator, I get 2 plus square root 3 in the numerator and same thing in the denominator. Now in the numerator, when I multiply by square root 3, I get 2 square root 3 plus square root 3 times square root 3 is 3. And in the denominator, we get 2 square, which is 4, minus square root 3 square, which is 3. 4 minus 3 is 1, and so we get a simplified form, 2 square root 3 plus 3. You get the idea. That is how we actually simplify the radical expressions. I hope the concept is absolutely clear. Now with that, let's look into our bonus question and some important concepts which we learned in this particular video. So radicand is an expression under the radical sign, as I was saying, and simplify radicand really means the following. 1. Radicand will not have any perfect square factor. So from 8 we took out 4, from 27 we took out 9, from a cube we took out a square. So perfect square factors were taken out. And then here is a question of the day which involves rationalization. Rationalization because the second condition says radicand will not appear in the denominator. So if it appears in the denominator, in that case you have to rationalize. It could appear in denominator as seen in the third set, or it could appear just as it is. So in either case we have to rationalize. And so based on this, here is your bonus question. You need to simplify square root of 8a cube b over square root 27c squared. I hope you find my video interesting and useful. Feel free to write down your comments, share your views, and if you like and subscribe to my videos, that will be great. Solution of this will be also posted. So keep watching the videos and keep learning. Thanks for your time and all the best.